Hey, what's going on guys? In this video we are going to see an example of cascaded op-amp circuit. For a cascaded op-amp circuit, the output of the first op-amp is the input for the second op-amp, right? So here you can see this VO1 is going to be the input of this second op-amp. In this particular problem we are going to calculate this VO voltage. Now here you can see this, both of these input voltages are connected to the non-inverting terminal. In other words, you can say positive terminal. So when we have the input voltage connected to the positive terminal is non-inverting op amplifier, right? So for a non-inverting op amplifier, we use this equation to find out the Vout voltage. So VO1 is this voltage. For this voltage, we use this equation, that is RF over R1 plus 1 times V1. So this is the equation for the non-inverting op amplifier. In our case, let's call this one RF1 because this is RF1. So 8 kilo ohm divided by 2 kilo ohm plus 1 times the voltage input. So let's call this one VI1, and it's better to give a value. Let's give 100 millivolt. So we have to multiply this one by 100 millivolt. So let's multiply this one with 100 millivolt. Here we are going to get 4 plus 1, that's going to be 5. 5 times 100 millivolt, that's going to give us 500 millivolt. And for the second op amplifier, the same equation, because this is also connected to the non-inverting terminal. So VO is also going to be equivalent to RF2. Here we have RF2 divided by R2 plus 1 times the input voltage, that is 500 millivolt. 500. So let's write VO1 first because we are writing the general term. So this is VO1, and here we are going to have RF2 is equal to 10 kilo ohm divided by 5 kilo ohm plus 1 times VO1, that is equivalent to 500 millivoltage. 2 plus 1, 3. 3 times 500 millivoltage, that's going to give us 1500 millivoltage. In voltage we are going to have 1.5 volt, and that's how we calculate voltage output for a cascaded op amplifier. I hope this helps. Thanks for watching.